Hello everyone. I'm here to share a review of the journal article analyzed for Revila thesis. This review highlights the key finding and insight from the studies she explored. Let's dive into how these studies contribute to our understanding of the influence of lightweight steel mixture on concrete strength. Concrete is a widely used construction material known for its high compressive strength, but it has relatively low tensile strength. To improve the tensile performance of concrete, researchers have explored the use of various admixtures, including lightweight steel fiber. This study investigates the effects of inconverting lightweight steel fiber at varying percentage 0%, 10%, 15%, and 20% on the compressive and split tensile strengths of concrete with a target strength of 20 MPa at 14 and 28 J. The findings provide insights into the optimal proportion of lightweight steel fibers to enhance the concrete's overall structural performance. Okay, experimental methodology. Material characterization. The study began with a thorough investigation of the physical and mechanical properties of the concrete constituent, including fine and coarse aggregates, cement, and the lightweight steel fiber. These tests were conducted in accordance with relevant ESTM standards to ensure the material met the specified requirements. Uh, Second, mixture design. The concrete mix was developed based on the principle outlined in SNP 7C56 2012, which is an adaptation of SCI 211 method. The required quantities of each ingredient, including water, cement, fine and coarse aggregate, and the varying percentage of light steel fiber, were determined for the 28 concrete cylinder specimen. Third, testing program. The prepared concrete specimen were subject to a series of tests, including slump, unit weight, and specific gravity measurement, as well as compressive and split tensile strength evaluation at 14 and 28 days of curing. The results were analyzed to investigate the influence of the lightweight steel fiber addition on the concrete mechanical properties and material properties. First, fine aggregate. The fine aggregate used in the study was thoroughly tested to ensure compliance with the STM specification. The result showed that the fine aggregate had a low seed content of 2.63%, a unit weight of 1.302 kg per liter in the loose state and 1.592 kg per liter in the compact state, and a specific gravity ranging from 2.47 to 2.94, all of which met the required standard. And coarse aggregate. The coarse aggregate also underwent extensive testing, including measurement of unit weight, absorption, and abrasion resistance. The results indicate that the coarse aggregate had a unit weight of 1.288 kg per liter in the loose state and 1.481 kg per liter in the compact state, and absorption of 1.97% and Los Angeles abrasion value of 20%, all of which were within the acceptable limits. Next, lightweight steel fiber. The lightweight steel fiber used as the admixture in the study were carefully selected and characterized to ensure their compatibility with the concrete mix. Their physical and mechanical properties were thoroughly evaluated to understand their potential impact on the concrete performance. Workability and density. 1. Slump test result. The initial slump test on the flank concrete mixture indicate a value less than the target of 75 mm, prompting the addition of extra water to achieve the desired workability. The slime values for the concrete mix with 0%, 10%, 15%, and 20% lightweight steel fiber addition were all maintained at 80 mm through the appropriate adjustment of the water content. 2. Unit weight. The unit weight of the concrete specimen was measured, and the result showed that the concrete with 15 lightweight steel fiber addition had the highest unit weight of 2,355.96 kg per meter cubed, while the 20% fiber concrete had the lowest unit weight of 20,289.97 kg per meter cubed. The variation in unit weight were attributed to the difference in the fiber content and the corresponding impact on the concrete density. Okay, specific gravity. The specific gravity of the hardened concrete specimen was also determined, with the 15 lightweight steel fiber concrete exhibiting the highest specific gravity of 2,310.38 and the 20% fiber concrete, having the lowest at 2,244.34. This difference in this specific gravity reflects the change in the concrete composition and density due to varying fiber contents. Compressing strength result. 14th-day compressive strength. At 14 days of curing, the concrete with 15 lightweight steel fiber addition had the highest applied compressive strength of 20.162 MPa, representing a 43.33% increase over the flame concrete strength of 8.485 MPa. The 10% and 20% fiber reinforced concrete also exhibited compressive strength improvement of 40% and 10% respectively compared to the control mix. And 28-day compressive strength. At 28 days, the plain concrete with any fiber addition had the highest accurate compressive strength of 13.857 MPa. The 10%, 15%, and 20% fiber reinforced concrete saw a decrease in compressive strength of 40.82%, 14.2% to 27%, and 48.98%, respectively, compared to the control mix. This suggests that the lightweight steel fibers were more effective in improving the early age compressive strength rather than long-term performance. Optimum fiber content. Based on the compressive strength result, the optimal lightweight steel fiber content appears to be 15%, as it provides the maximum compressive strength improvement of 43.33% at 14 days. This indicates that the addition of 15% lightweight steel fiber can be an effective way to enhance the early age compressive strength of concrete, although the long-term benefit may be limited. Split tensile strength evaluation. Tensile strength at 14th day. The split tensile strength test conducted at 14th day revealed that the concrete with 10% lightweight steel fiber addition had highest average split tensile strength of 2.183 MPa, representing a 24.09% increase over the flame concrete tensile strength of 1.757 MPa. This suggests that the addition of 10% lightweight steel fiber can effectively improve the concrete early age tensile performance. And then tensile strength at 28 days. At 28 days, the plain concrete without any fiber addition exhibited the highest average split tensile strength of strength 1.757 MPa. The 10% and 15% fiber reinforced concrete saw decrease in tensile strength of 10.23% and 0.5% respectively compared to the control mix. This indicates that the optimal lightweight steel fiber content for maximum tensile strength is 10%, as it provides the maximum improvement of 24.07% at the earlier age. Influence of fiber addition on strength properties. First, compressive strength. The incorporation of lightweight steel fiber had a significant impact into the concrete compressive strength, particularly at the early age of 14th day. The 15% fiber addition exhibited the highest compressive strength with a 40.30% increase compared to the flame concrete. However, the long-term compressive strength at 28 days was highest in the control mix without any fiber addition. And tensile strength. The split tensile strength of the concrete was also influenced by the addition of lightweight steel fiber. The 10% fiber content provides the maximum tensile strength improvement of 24.09% at 14 days, indicating that this proportion is optimal for enhancing the concrete early age tensile performance. At 28 days, the plain concrete exhibited the highest tensile strength and density. The variation in the lightweight steel fiber content affected the density of the concrete specimen. The 15% fiber reinforced concrete had the highest unit weight and specific gravity, while the 20% fiber concrete had the lowest, suggesting that the fiber addition can influence the concrete overall density and compactness. Practical implication. First, early age strength improvement. The study finding demonstrate that the addition of lightweight steel fibers, particularly at the 15% level, can significantly improve the concrete compressive strength during the early stage of curing. This could be beneficial for construction projects where early strength development is crucial. such as precast concrete element or fast strike construction. 2. Optimizing tensile performance. The optimal 10% lightweight steel fiber content was found to provide the maximum enhancement in the concrete split tensile strength at 14th day. This information can be valuable for structural application where the concrete needs to resist tensile stresses, such as in flexural members of tensile dominant load case. 3. Density consideration. The variation of the concrete density due to the different fiber contents should be considered during the design and construction stage, as they can affect factors such as infrastructure weight, transportation, and handling requirements. The 15% fiber reinforced concrete had the highest density, which may be a desirable characteristic in certain applications. For limitation and future research. Limitation, limited fiber variation. Explanation. The study only investigates three specific fiber content percentage, 10%, 15%, and 20%, which may not have captured the full range of potential strength improvement. Future research could explore a wider fiber proportion to identify the optimal blend more precisely. For limitation single concrete strength grades, the research focused on the target concrete strength up to 20 MPa, which may not be representative of all concrete applications. Evaluating the influence of lightweight steel fiber on concretes of different strength grades would provide a more comprehensive understanding of their performance capabilities. Limitation: absence of long-term durability assessment. The study primarily examined the short-term mechanical property of the fiber reinforced concrete, but the long-term durability and performance under sustained loads were not evaluated. Future investigation should consider the long-term behavior and potential serviceability issues that may arise from the fiber addition. Okay, conclusion and recommendation. First, key finding. The study demonstrated that the incorporation of lightweight steel fiber can have a significant impact on the concrete compressive and split tensile strength, particularly at the early stage of curing. The 15 fiber addition provide the maximum compressive strength improvement of 43.30% at the 14 days, while the 10% fiber content result in a 24.09% increase in split tensile strength at the same age. 2. Practical implication. The finding suggests that the strategy use of lightweight steel fiber in concrete can be beneficial for applications where polyedge strength development is crucial, such as in precast element or fast strike construction. The 10% fiber content can also be advantageous for enhancing the concrete tensile performance in flexural or tensile dominant structural members. Last, future research direction. To further optimize the use of lightweight steel fiber in concrete, future research efforts should explore a wider range of fiber content variation, evaluate the performance of different concrete strength grades, and assess the long-term durability and serviceability of the fiber reinforced concrete. This will provide a more comprehensive understanding of the benefit and limitation of this innovative construction material. Okay, thank you for attention. I'll say goodbye.